Hello and welcome back. We have seen that the model is giving 97.97% accuracy on train set and test set. But I said accuracy is not a good metric for an imbalanced data set. Let us try to understand what is imbalanced data set. In a classification problem, if class distribution is not uniform among classes, then we call it as imbalanced data set. What I am saying is class distribution is not uniform among classes. Right? If you take a data set, there are 40,000 records and 20,000 records belonging to 0 and 20,000 records belonging to 1, then we say the class distribution is uniform. In this particular data set, whatever we have taken, 5s and not 5s, we have got total records 42,000 and the records belonging to 5, 38,205. And the records not belonging to 5 are 3795. Only 10% of the records are belonging to one class and 90% records belong to another class. So the class distribution is not uniform. So we can say this data set is imbalanced. When the data set is imbalanced, the accuracy measure will not work. Why the accuracy measure will not work or will not actually show you the error metric properly, we'll see that with a simple example. If you see this data set, there are only 10 records. Don't care about x's. There is one y, right? The record, there are 9 records belonging to 0 and 1 record belonging to 1. This is also an imbalanced data set. 90% of the data belongs to 0 class, and 10% data belong to 1 class. The class distribution is not uniform. Suppose that there is a model which is predicting all zeros, right? The y cap is all zeros here. The accuracy measure actually gets counted like this: count of correctly predicted divided by total records. That's the formula for accuracy measure, accuracy score. Count of correctly predicted is how many? 9, and total is 10. So 90% accuracy we got. If I see this, there is no intelligence for the model which predicted all zeros for records. At all records it predicted 0, there is no intelligence. It literally understood nothing. But still, the accuracy measure is actually giving you a wrong impression that the model is working good. If you continuously pass records belonging to 1, maybe 10 records, all it will predict 0. That means you will get 0% accuracy on the test set or production. So the accuracy measure, the formula is not well suited for imbalanced data set. This is an imbalanced data set and you can see clearly what is happening. In that case, how to measure our model's accuracy? We have built a binary class classification problem for knots and 5s and not 5s. How to measure it? There are measures. So we have confusion matrix, which actually takes into consideration of positive class predicted as positive, the count of positive class predicted as positive, the count of negative records predicted as negative, the count of positive records wrongly classified as negative, and count of negative records wrongly predicted as positive. 4 cases are there. In accuracy measure, it is actually looking at whether the record is predicted as correctly or not. So it is looking at a negative record, a record belonging to 0 is predicted 0 or not. A positive record, 1 predicted as 1 or not. That's the only count it is trying to look at. But the confusion matrix is actually trying to look at the other 2 cases also. How many positive records wrongly predicted as negative and how many negative records wrongly predicted as positive also. When you look at this, you will get a clear picture of what is happening with the model or the metric is always to show you how the model is working. If on an imbalanced data set, if you are using accuracy measure, it is going to give you a wrong impression that the model is working good. And if you take this into consideration and put the model into production, it will not work. So you need to take the advanced metrics like confusion matrix, precision recall and F1 score. So if you look at this confusion matrix, row wise you will actually see actuals and the columns are predicted. So it actually gives you a count of number of records which are actually negative, predicted as negative here, that is correct prediction, and actually positive and predicted as positive. When I say positive and negative, positive means record belonging to 1, negative means record belonging to 0. So it gives you those counts, and it gives you the wrong predictions also. The negative actual record belonging to 0 and predicted as 1, and actual record belonging to 1 and predicted as 0. So all 4 cases it will actually consider, and when you look at these scores, you will understand how the model is working. For our data set, for our model also we have done it. If you look at this, there are 30,444 plus 134 number of not 5 records are there in train set, and the model predicted 30,444 records as 0, that is correct prediction, right? Not 5 means 0 and 5 means 1, and 134 records it predicted as 1, that means wrongly predicted 134 records wrongly predicted as belonging to 5, even though the record belongs to not 5. And then on the actual side, there are 702 records which are wrongly predicted as not 5s, even though record belongs to 5, and 2320 records which are belonging to 5 are predicted as 5. So this is a confusion matrix which actually gives you clear picture of what's happening with the model, instead of looking at the percentage and accuracy score. So let us try to see how to do this with code, using code. So here there is a method called confusion matrix in scikit-learn's metrics, and you can actually pass your actual y values and the predicted y values. I am directly using the model.predict and passing x train. So if you try to execute this, it will actually give you the scores, the same scores I actually showed there. So using these 4 scores, you can calculate precision and recall, and using those 2 scores, you can calculate FM score, which actually gives you consolidated understanding of whether model is working good or not. So we'll see those in coming session. Thank you.